There is a persistent assumption in modern education policy. Swapping out old classroom tools for interactive screens automatically turns passive students into active learners. That specific logic drives billions of dollars in technology spending and curriculum reform across the globe every year. But a 2026 Action Research study examining secondary schools in the Laos PDR offers a strict reality check. Researchers tracked exactly what happened when these regional schools successfully integrated new instructional media into their geography curriculums. The baseline conditions in these classrooms are challenging. Instruction relies heavily on rote memorization, classes are overcrowded, and digital infrastructure is scarce. When the instructional media was introduced, the top-line results looked fantastic. Student satisfaction spiked, and academic performance evaluations reached the very good tier across the board. Yet the classroom observation data revealed a structural paradox. Despite the high test scores, the core learning model had not shifted. The environment remained entirely teacher-centered, with almost zero independent student inquiry. The data demonstrates that introducing new educational tools into a traditional environment often just optimizes the efficiency of passive instruction. Purchasing new hardware solves very little if it outpaces a school's pedagogical architecture. An efficiently run passive classroom is still a passive classroom. Geography is an inherently spatial and abstract field of study. Mapping large-scale physical processes or global trade routes places a massive demand on a student's working memory. When complex spatial information is delivered through verbal instruction, working memory reaches extraneous cognitive load. The mental model becomes too heavy, and comprehension collapses. Educational psychologist Richard Mayer's cognitive theory of multimedia learning explains exactly why this happens. Humans process incoming information through two distinct channels, one for words and one for pictures. A traditional talk and chalk lecture forces every piece of geographic data through the verbal channel alone. That pathway bottlenecks, causing the cognitive overload. Teachers in the Laos study bypassed this bottleneck by leaning heavily into analog physical media, bringing globes, maps, and physical models directly into the lessons. By rerouting the abstract spatial data through the visual channel, the students effectively doubled their working memory capacity. The cognitive load stabilized. This specific distribution of mental processing power is exactly why the academic performance and satisfaction scores in those classrooms spiked so dramatically. You do not need glowing smartboards or expensive tablets to achieve high cognitive efficacy. Basic analog tools that successfully engage both processing channels are entirely sufficient to eliminate cognitive overload. We know the physical media solved the cognitive processing problem, but to understand the true impact on learning, we have to look at how the teachers actually deployed these tools in the room. This chart shows the clear usage patterns documented in the study. Physical globes, maps, and contextual visits to libraries saw extremely high utilization, while electronic media and digital instruments remained low. The type of media successfully lowered the cognitive burden. However, the accompanying classroom behavior data exposes a serious systemic trap. When evaluating how instructional activities were organized, 3 metrics scored higher than a 4.5: the teacher presenting objectives, the teacher connecting prior knowledge, and the teacher allocating information on the board. Notice the pattern. These highest scoring activities are strictly teacher-led mechanisms delivering information to passive audiences. Now look at the bottom of the same survey. The lowest scores were recorded for promoting student creativity, encouraging independent answers, and allowing students to summarize material. The gap between these two data sets is incredibly telling. The classroom is highly organized and the lesson is coherent, but the structure leaves almost zero room for generative thinking or independent student inquiry. The physical media is acting strictly as a megaphone for the teacher's lesson plan, rather than functioning as an exploratory sandbox for the students to test their own ideas. Inserting visual media into a rote learning environment does not create active learning. It simply produces highly optimized, cognitively efficient passive learning. This dynamic extends far beyond a single classroom in the Laos PDR. It directly reflects the broader policy landscape of the entire ASEAN region. Many developing Asian nations share these exact structural constraints. Right now, they are aggressively pushing digital curriculum reforms to keep pace with modern economic demands. We evaluate this using a simple matrix charting pedagogical agility against media integration. The Laos study lands in the upper left quadrant, high media use, low agility. This is the efficiency trap. Genuine sustainability requires shifting to the top right quadrant of constructivist, inquiry-based learning. Across the region, the scarcity of specialized teacher training remains a more severe constraint on progress than the physical absence of maps, projectors, or broadband. Instructors require sustained professional development to learn a difficult skill, how to step back. They have to allow students to manipulate and interpret the media themselves, rather than just consuming a teacher's presentation. Hardware is inert infrastructure. Transitioning students from passive consumption toward active, independent inquiry requires policymakers to focus on upgrading the pedagogical operating system.